Coulomb's law. Coulomb's law is a quantity statement about the force between two point charges. Let us consider two charges, Q1 and Q2, separated by a distance r. There is a force acting in between these two charges. The force between the 2 point charges and found that it varied inversely as the square of the distance between the charges and was directly proportional to the product of the magnitude of the two charges. And this force acts along the line joining the two charges. Force F is equal to K into Q1 Q2 by R square. K is a constant and that is given by 1 by 4 pi epsilon 0 into Q1 Q2 by R square, where epsilon 0 is called the permittivity of free space. The value of epsilon 0 in SI unit is epsilon 0 is equal to 8.854 into 10 raised to minus 12 Coulomb square, Newton raised to minus 1, meter raised to minus 2. Let us learn a new term in electrostatics, that is permittivity. It is represented by the letter epsilon. Permittivity of free space. Epsilon 0 is a physical constant used in electromagnetism. It represents the capability of vacuum to permit electric fields. It is also connected to the energy stored within an electric field and capacitance. Of the medium epsilon is the capability of a medium to permit electric fields. It is a physical constant of the medium used in electromagnetism. The relation between epsilon 0 and epsilon is known as relative permittivity, that is epsilon r. Relative permittivity is defined as the ratio of permittivity of the medium to permittivity of free space. Epsilon r is equal to epsilon by epsilon 0. It's a mere number. We know epsilon 0 is equal to 8.854 into 10 raised to minus 12 Coulomb square, Newton raised to minus 1, meter raised to minus 2. The value of K is equal to 1 by 4 pi epsilon 0. If we are putting the value of epsilon 0 in this equation, 1 by 4 pi epsilon 0, we obtain the value 9 into 10 raised to 9. So the value of 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. Putting this value of K in equation, F is equal to K into Q1 Q2 by R square. That is, F is equal to 9 into 10 raised to 9 Q1 Q2 by R square. Suppose if we are considering two charges Q1 and Q2 of 1 coulomb separated by a distance 1 meter, we can substitute these values of charges and distance in the equation. F is equal to 9 into 10 raised to 9 Q1 Q2 by R square. We will obtain F is equal to 9 into 10 raised to 9 Newton into 1 into 1 divided by 1 square. So the value we obtained is the force between these two charges of 1 coulomb separated by a distance 1 meter is 9 into 10 raised to 9 Newton. So we can define 1 coulomb of charge. 1 coulomb is the charge that when placed at a distance of 1 meter from another charge of the same magnitude in vacuum experiences an electric force of repulsion of magnitude 9 into 10 raised to 9 Newton. So two charges, 1 coulomb and 1 coulomb, separated by a distance 1 meter. The force between these two charges is 9 into 10 raised to 9 Newton. In this way, we can define 1 coulomb. 1 coulomb is evidently too big unit to be used in practice. We are using smaller units like 1 millicoulomb, 1 microcoulomb, etc. Since force is a vector, it is better to write Coulomb's law in vector notation. Let us consider two charges, Q1 and Q2, with the position vectors R1 and R2. Since both these charges are of same sign, there will be a repulsive force act between the charges. Force on Q1 due to charge Q2 is F12. Similarly, force on Q2 due to charge Q1 is F21. The corresponding vector from Q1 to Q2 is R21. R21 can be represented as R21 is equal to R2 minus R1 to denote the direction of a vector. From the diagram, it is seen that force on charge Q1 due to charge Q2 is equal and opposite to force on charge Q2 due to charge Q1. Therefore, F21 is equal to minus F12. Thus, Coulomb's law agrees with Newton's third law. Forces between multiple charges. Consider a system of three charges Q1, Q2 and Q3 as shown in the figure with the position vectors R1, R2 and R3. The vector leading from Q3 to Q1 is R13. The vector leading from Q2 to Q1 is R12. We are going to find force on charge Q1 due to charge Q2 and Q3. The force experienced by Q1 due to charge at charge Q2 is represented by the vector F12. The force experienced by the charge Q1 due to charge Q3 is represented by the vector F13. F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square. Similarly, F13 is equal to 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 square. The force on charge Q1 due to the charge Q2 and Q3 are not in the same direction. They are at two different directions. So we have to find the net force on charge Q1 by applying parallelogram law of vector addition. For that, we have to complete the parallelogram. By completing the parallelogram, the diagonal which gives us the resultant force F. F can be written as F is equal to the vector F12 plus the vector F13. You already know the force is a vector. So we have to consider the vector addition of forces. Here we are using parallelogram law of vector addition. Let us define principle of superposition. In the previous case, we already seen that force on any one of the charges due to other charges. Force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to the other charges taken one at a time. The individual forces are unaffected due to the presence of other charges. Let us consider more than three charges system. It is multiple charges again. Let us consider 8 charges Q1, Q2, Q3, Q4, Q5, Q6, Q7 and Q8. The force on charge Q1 due to charge Q2 is represented by F12, Q2 is represented by F13, Q3 is represented by F14, Q5 is represented by F15, Q6 is represented by F16, Q7 represented by F17 and Q8 is represented by F18. It is seen that all these vectors are in different directions. So how can we find the net force on Q1 due to all other charges around it? Here we can find the net force on Q1 due to all other charges by applying the law of vector addition, that is polygon law of vector addition. Polygon law of vector addition, all the vectors are represented as the side of a polygon. The open side, which is in the opposite direction, we consider a vector. It will F1 represents the resultant of all forces by using polygon law of vector addition.